Okay, so today we're talking about geometric sequences. And if you've never seen one before, we have a few examples. So for the first one, we have 1 followed by 2, and then 4, 8, 16. And the general rule for a geometric sequence is that between consecutive terms, we are multiplying by a fixed number. So here we see for the first one, we have 1, then 2, so we've multiplied by 2. And then the second and third terms, we've again multiplied by 2, and this carries on until infinity. So I can just write r to be this number, so r equals 2 here. And generally, r is called the common ratio. So another important bit of information is where the sequence starts. So for the first one we have, I'm going to call this a, we have a equals 1. And these two bits of information really define a geometric sequence. So let's look at the other two. For the second one, we again have the starting point is a equals 1, but the ratio now isn't an integer, it's actually a fraction. So we see we've divided by 3 to get from the first term to the second term, and that's the same as multiplying by a third, so our ratio is 1 over 3. And this carries on down the sequence, and this really defines the sequence. So let's look at the last one. Now this is a bit tricky because we see that the sign is changing. So on the odd terms, we have positive numbers, but on the odd terms, even terms, we have negative numbers. And that tells us our ratio is going to be negative, because the sign is changing every other term. So our ratio is going to be negative, and the size of the numbers that are changing, we have 2, then minus 10, so it's going to be minus 5. And we see 2 times minus 5 is minus 10, multiply that again by minus 5, we get 50, and this carries on. So last thing is, this time we are not starting at 1, we're starting at 2. And this can literally be any number you like. So now that we've seen a few examples, let's think about the general form for a geometric sequence. So we've said that these two bits of information really define a sequence. So for a general geometric sequence, we're going to have a first term, which we call a, just like we did before. And then what do? So to get to the second term, we are multiplying by this number r. So the second term is a times r. And then for the third term, this is the same thing. We multiply the previous term by r again. So we get a times r, which is ar squared. And then the fourth term is ar cubed, and this carries on until infinity. So this is really the general form of a geometric sequence, where a is the initial value and r is the ratio. And then we can think about the general nth term in the sequence. So if we want to find out the value of the term in the sequence at the nth position, what is this given by? Well, we can just think about following this pattern. So let me call un to be the nth term in the sequence. And so our first term is a, we're going to need an a in all of these, and we need an r to the power of something. So we just need to figure out what the power is, and we want it to start off. So if we put n equals 1 in here, we want it to give out a. So that tells us we need r to the power of n minus 1. So if we put n equals 1 in here, this simplifies to r to the power of 0, and that's just 1. So we are left with u1 equals a. And then increasing the number by 1, we put u2, then we get a times r, which is what defines the sequence. So at any position in the sequence, we just plug in the numbers here, and this gives us the value of that term. So now we're just going to look at a problem involving geometric sequences, just to make sure we understand it. I'm just going to rub out the board, and then we'll look at it. Okay, so let's look at this problem. We're given a geometric sequence, which the first 3 terms are given by 3, then x, which is a variable, and then the third term is x plus 6. And the question is to find the possible values for x such that this is a geometric sequence. So we really need to understand what is a geometric sequence. And so to solve this problem, we need to think about the common ratio. So remember that to get between terms, we are multiplying by a number r, and this is fixed. So the number that we multiply by here is the same to get from the second to third term. So we multiply by r again. And so a way to find out what x is, we can think about the ratio between terms. So if I just denote un to be the nth term, which is the same notation we were using before, then we can think of the second term divided by the first term, which will be x divided by 3. And this is going to equal r. This is going to be equal to our common ratio, the number we're multiplying by, just because this is the rule. And we also know that this ratio is constant for all the terms in the sequence. So this is going to be the same as u3 divided by u2. So the ratio here isn't important. What is important is that we can plug plug in these numbers and try and find out what x is. So if we do that, we have x divided by 3, that's u2 divided by u1. This equals x plus 6 divided by x. So this is just u3 divided by u2. And now we have an equation involving the variable x, and this is actually going to turn out to be a quadratic equation, which we can solve. So if I just cross multiply, bring the x up, we have x squared on the left side, and I'm going to multiply by 3 on the bottom to get 3x plus 18 on the right hand side. So I've just multiplied by x and multiplied by 3. And then we can bring everything onto one side, so x squared minus 3x minus 18 equals 0. And this is a very standard quadratic. You can use the formula or complete the square, however you want to do it. We can actually factorize this. It's going to be a little bit quicker. So if I just go up here, the roots of this quadratic, we can factor it as, so it's going to be 2 terms like this. And we know that, well, the factors of 18, so it's 6 and 3. And then we also have that minus 6 plus 3 equals minus 3. So we can choose minus 6 here and plus 3. And then you see if you multiply this out, we're going to get the minus 18, and you're also going to get the minus 3x. So this is how we factorize this, and then this tells us the solutions. We can just read them out. Just make the brackets equal to 0. So we have x equals 6 and x equals minus 3. So just to recap, these values of x are the only times where this sequence would be a geometric sequence. And we can actually think about plugging these numbers in to see what they'd give, just to double check. So if we look at the first one here, x equals 6. So we have 3, and then x is 6 now. And then we have x plus 6, so 6 plus 6, which is 12. And this carries on like this. And we see here, this time, the ratio is 2. So we multiply numbers by 2 every time. And this is a geometric sequence, which is nice. So let's also think about this value of x. It's negative this time. So if I just go down here, our sequence now is 3. That's the same first term. And then we get minus 3. And then we have x plus 6, which is minus 3 plus 6. And that's going to be plus 3. And this carries on. So the size of the numbers isn't changing, just the sign. And that's fine because we see that we're multiplying by minus 1. That's all that's changing, just the sign. So this is kind of, it's still a geometric sequence. It's kind of a special case because the numbers aren't going anywhere, but just the sign's changing. That's fine because we're multiplying by a common ratio. So this is just a good way to check that we understand what geometric sequences do.